Okay, let's go ahead and get started. Today we've got a nice webinar. Mary Thomas, the SDSC training lead, is going to be telling us about how to run Jupyter notebooks on our newest supercomputer, Expanse. Before we get started, I want to point out the Exceed Code of Conduct. Generally, people are on their best behavior, but if you see any kind of behaviors that you feel the need to report, the information is on the slide, exceed.org/code of conduct. And we also want to emphasize the importance that we are being very sensitive to terminology in our training materials. So if you come across anything that you think is inappropriate, please let us know about that as well. Okay, and with that, then I will stop sharing and let Mary Thomas take over. Take it away, Mary.
Thanks, Jeff, and welcome everybody, and thanks for taking time. Jeff, you need to enable me so I can share.
Sorry about that, my mistake.
No problem. Okay, let's make sure you can see my desktop and my slides. Go into presentation mode. Is everything good and is nothing blocked? There's sometimes that little
that helps. Yeah,
screen share thing. Okay, so welcome everybody, and thank you again for taking some time out of your busy schedules to come to our webinar. The motivation for this is notebooks are very, very popular, and they're being used by many people for a lot of different applications. Sorry about that. And so today I want to talk about our motivation for the project of that we've been working on called the Jupyter Reverse Proxy Service. And it came out of an interest in improving the security of notebooks. So that's one of the reasons we do these notebook webinar series. And the other one is Expanse is a little bit different than Comet. And for those of you who've been running jobs on Comet, you'll find that there are some slight differences, especially in the module environment. So we also want to be able to address that, but just also keep reminding people. And I'll talk about, Jupyter notebooks, a quick overview for those of you who've never seen them, then talk about our security concerns and what we're doing at SDSC to help contribute to solutions with the Jupyter community, and then the software requirements for running notebooks on Expanse, and then different methods for running notebooks. There are methods that range from completely insecure over HTTP to more secure. And I'll talk about those, and then describe the reverse proxy service and why we're recommending that people start using it. And hopefully I can do a live demo. We'll see, but I have pictures that will also serve as a reference. So some basic information. There's the Expanse user guide. Again, this is a new machine and there are some key differences. And if you haven't gotten onto the machine yet, go ahead and take a look at the user guide and look at the webinar that we did last month on Expanse 101. I'll show you those links and show you the site when we're done. And you need to have an account to get onto Expanse. You can apply for a trial account, which happens very quickly, relatively speaking. And then you can also get longer allocations like a startup, which can run from 1 to 3 years without going through a full review. It gives you a chance to port your code. The online repo for this webinar is I'll show you that link. And then basic skills. There are some basic things that you need to know in order just to run code and interact on HPC environments. And so we've put together a few simple guides that get you started, and then you can go deeper if you want. If you want to know more about our training program, just go to the training website. We have a GitHub repository with lots of different repos that are generated from our webinars and other aspects of our training. And then Jeff takes these videos and converts them to an interactive video. And then we also include links to the repo, the PDF of the talk, some code if it's related to the webinar. So these take a few days though, but when you're done, you can navigate through the video and find parts in the transcript and parts in the talk that are correlated, and dive in where you want. So to get the notebooks, and I'll show you an example, you can clone the repository and then start working with it. If you don't know Git clone, in our basic skills repo, it'll help you how to do a little bit. I want to start though with a big warning. Jupyter notebooks should not be run on the login nodes. Those jobs will be deleted. We are reducing the load on the login nodes because with 10 to 20,000 people running jobs, it gets very busy. So if they get found, they will be deleted. That's just a policy that we're starting to enforce more and more. So a quick overview of Expanse, and again, if you don't know about Expanse, it's an extension of Comet. So computing without boundaries is the goal, and we're also still dedicated to the long tail of science, meaning those jobs that don't require petascale resources, but there are more of us out there requiring modest scale resources now, terascale, or a little bit larger. And so thousands of nodes is the goal of our jobs, and that's how our schedulers are optimized. So if you get onto Expanse, that's what you can expect. If you have a much bigger application, then you need to go to some of the other resources on Exceed, and the consultants will help guide you there. There are, it has 13 of these scalable compute units. I'll describe those in a moment. 728 standard compute nodes, 52 GPU nodes with 208 GPUs, large memory nodes. It's a data-centric architecture, so we have high-speed internal networking and also Ceph object storage. And again, the long tail, and it has some innovative features now. Composable systems is a new feature. I'll talk about that in a moment, so that we can do edge computing around the boundaries of computational resources, science gateways, interactive computing, which is where the notebooks fit in, and containerized computing and cloud bursting. So some of these are new and novel in research activities, and they'll be available maybe, in the next year. So it's a heterogeneous architecture. So we have these scalable compute units, and they stand alone. What we've done is put CPU and GPUs on each of the racks. So there's 13 of these racks with, again, a large number of nodes and cores and a lot of data. I'm not going to go into great detail. Again, you can go back to several of our talks and go to the website to get more information. It's designed for the long tail, as I said. So that's why each rack contains CPU and GPU, so that they're close to each other. And the modest scales of the jobs, but a lot of them, is the goal for what we're supporting on Comet. The connectivity fabric is pretty advanced. Ceph object storage, high performance Lustre storage, connections to a tremendous number of high-speed external networks, and a campus DMZ. So you should connecting with Globus and other tools. The processor architecture, this is a really key aspect of Expanse. Is the AMD EPYC processor is very powerful, but very complicated. It has these CCD devices. They're interconnected with their own network and local cache. And tuning to the EPYC architecture can take some thought. And we're planning an advanced user training for Expanse users in the spring. And the ECSS staff just got some training on EPYC. And once you get your code tuned, it's pretty fast. It's got some good performance numbers. Again, we are doing a lot. We have a forum for the AMD user forum that we kicked off to exchange information for getting your code up and running. Composable Systems is a research project led by Dr. Ilkay Atkas, and it's looking out at using a cluster manager with Kubernetes to launch systems dynamically, and they're composed of a lot of different resources that are out there, and you can launch to it. You'll be able to launch to it from Expanse. Ilkay will give a talk on this in the spring, and we're hoping to allocate resources to it in the summer. So you can't access this unless you get an allocation, but you can take a look at this, go to this talk in the spring. You can see it on our training schedule and learn about it and see if this might be something that you would want to use. People using composable systems will get ECSS support as well. Integration with public cloud. Trevor Cooper has been leading this effort to have the Slurm scheduler dynamically decide for you if you have allocations out on the cloud. Right now it's with Amazon Web Services. If the Slurm is too busy, then it will launch launch jobs for you out on the cloud. So we're pretty excited about this capability, which might be coming on board for general use in the fall. I'm not sure about the timeline yet. The status Expanse is in production now, effective 12/7. There's been an early user testing phase, and now anybody who has Comet allocations, you're welcome to start transferring your allocations over to Expanse. And there's some formula for converting your SUs over to the Expanse, and the Exceed team consultants can help you with that. A warning: when you get your account, you will not inherit any of your common environment. No directories, no code, no anything. You start with pretty much of an empty directory. So you'll want to learn about that. We have a transition workshop we hosted a few weeks ago, and we'll do this again in March. You can go online and look at the training material and get an idea of the things that we think are important, from the file system to the modules to the queuing system is Slurm. It's pretty similar to the way things work on Expanse with a couple of differences, and the way our GPUs are configured. So go back to our webinar that we had last month on Expanse 101, and it highlights a few of the differences. So with that, we'll start talking about running notebooks. Many of you are familiar with notebooks. They're very popular. You can install them on your desktop using an application called Anaconda. There's labs, Jupyter Labs and Jupyter Notebooks. The Jupyter Lab is basically the next generation of notebooks, and it gives you a shell terminal and a lot of features and capabilities. Jupyter Notebooks are run in Python, and you can do quite a bit with them now. This is an example of what it might look like on your desktop. You launch it through a web browser. This is the innovative feature about Jupyter. It can do advanced computing to HPC systems, and you do it from your web browser on your laptop. So it's pretty powerful. With that said, there's some gotchas, and you have to be careful and write your code securely. So this is just an example for plotting code. The requirements, it's not so easy to run the notebooks on HPC systems like it is on your laptop, because you have to communicate over a remote connection. So it's important to have a customized virtual Python environment. Packages that you might need in particular versions of Python or your plotting library, it might be different than the system supported ones, and the latency in keeping that updated, it's just too great. So we strongly, strongly, strongly recommend that you set up your own local environment. I'll show you how to do that. We recommend that you use Miniconda. You can also use Singularity containers, and Marty Candas is in our support group. He creates a lot of containers, and they're out there for you to access. But if you know how to make containers, you're welcome to use them. You can install and run them locally, though, so you're controlling your notebook environment. So Conda is a mini version of Anaconda. Here's the link to it. They have really good documentation on how to install. We have some notes in our user guide. It's created for the Python programs that run in Jupyter Notebooks, but as many of you might know, in Jupyter Notebooks, you can install different shell environments, and it can support Java, C, C++, Fortran, but mainly Python is what people use. They tend to use notebooks for like analyzing data or running machine learning programs, things like that. There's a good cheat sheet, and see our Notebooks 101 tutorial for more information on that. You can create a virtual environment with Conda. So let's say you have different applications, then you create a virtual environment for each of those apps, and it installs and keeps track of all the software that you need. I won't demo that today, but it's a pretty popular feature of Conda. A caveat about file systems, especially HPC. When you run things on your laptop, everything's right on that laptop. But when you're on an HPC system, the architecture is pretty complicated. You have login nodes, you have scheduling services, you have remote compute nodes, you have the GPU devices attached to the compute nodes. And so the program that you're writing has to be aware of where the data is that you need. You need to bring it in through a Globus IO capability. Do you have data on one node but not on another? So you even with Jupyter notebooks, you need to be aware of how to manage that. And so you have to be aware with Jupyter, where are you when you launch the notebook? We can talk a little bit about that, but just be aware you might launch your notebook excuse me, from your home directory, but you need to run it over on the work directory or /temp or the scratch, and the notebook won't be able to see it. So you might have to move everything and launch from the directory. That's not an Expanse feature. This is a notebook limitation. Just pointing that out. So an overview of notebooks. Let's see, notebooks this will be real quick. You can go to jupyter.org and they have tons of documents on them and tutorials and user guides. They're very popular. So most of you, if you're here, you've probably worked with them, but if not, we have some simple tutorials that will run for you when you do get them launched on Expanse. Why do we use them? Because they're so powerful and they simplify the developer environment, and they were created by scientists who do computational work and scientific work. And so it really meets the mentality of, I think, people who are doing scientific computing. And so you go in and it's like MATLAB or other like the RStudio, you're inside your code. And when you make changes, it happens real time. And I think of this as maybe the calculator of this century, but they're really popular, I think, because of their interactivity. So that makes us want to have them be running on HPC systems in an interactive way. So it's a community of open source developers that's just growing leaps and bounds. The goal is to build these open source tools and create a community that facilitates scientific research. On the previous slide, it showed a lot more Jupyter features and applications, and I'm not going to cover any of those. I'm just going to talk about notebooks today, but you can do an awful lot with Jupyter. They have binders and books and whatever. So it has over 100 programming languages and connects all kinds of tools. So the notebooks are web-based. This is a big feature. From your web browser, you can do this amazing interactive computing that 20 years ago wasn't even thought about, or where we'd hoped that we could get there in the early days. So it's all web-based form input. If you're a web developer, you understand the technology layer, but it isolates that from the users. You just go in and type 1 + 2 and it will give you 3. So it does support a collaborative community as well, and it does span a lot of disciplines. There's really no boundary for what the notebook can be used for. The boundaries would be, is your code requiring more memory or resources than you have on your laptop? Is your data large? So is it terabytes of data that's remote, and bringing that onto your laptop just isn't possible? These are the reasons you would move your Jupyter Notebook project to a big system like Expanse. In the back end, we can give you those capabilities. And machine learning is a really a good example of an application area, a domain that's just growing. And the requirements for machine learning, the data sets are so large, people can't really run them easily on their laptops anymore. So we're looking at supporting those areas. So basic architecture, you have a web browser, you have a service running on a machine, and that's the Jupyter server, the notebook server, and there's some kernel running, and there has to be a file system and some authentication. Jupyter Lab is, like I said, the next generation, and it gives you a lot more features like a shell. And we support both. You can launch notebooks and lab. So this is on my laptop using the Anaconda Navigator. I can launch a single notebook, and you can see there's my list of files that are in my notebook directory. And then over here, the Jupyter Lab allows you to have notebooks and tabs, so it's a little more advanced. And often these are hosted through Jupyter Hub, which is a server that runs on a machine and like an like Apache web-based kind of server, and multiple people can log in, so you can then support a community. And I'll talk to you about the security issues that we've found we're not comfortable with on our machines, and so we're working on a deep dive into making a more secure version of Jupyter Hub. Okay, so the security warning: the Jupyter Notebook URL is essentially a password. I could put the quote by Scott Sakai on here, our security expert. When you log into a Jupyter Notebook on your web browser, that is giving access to your directory on the machine, like on Expanse or Comet or your laptop. And so it's a password, and anybody who can come to your laptop and start typing on that browser can wreak some havoc. So you need to protect this, and you need to treat it very carefully, and don't share it. And also, when you shut down your notebook, make sure you've exited it completely. So there's different ways people run notebooks, and this sort of shows the scale from what we consider very insecure to more secure. And I would never say it was completely secure, because hackers are very smart. Anyway, by default, notebooks are run, this should say HTTP. They're run over HTTP, and that means that they're not secure. The communication between your laptop and the remote notebook server is not encrypted. It's open, vulnerable, it can be hacked. And this is the default mode of the Jupyter Notebook. So it's an insecure connection over HTTP. And by default, it would be running on the login node, which is against our policy. And this is the same for notebooks, Jupyter Lab, and Jupyter Hub. So we don't allow Jupyter Hub, for example, to run on our login nodes. We're working on a new authentication system to run it remotely. A little more secure. Well, here's another problem: is it runs as root. A little more secure is if you SSH tunnel, and I'll describe that, over to the remote server, then you get some encryption and security capability. The disadvantage is SSH tunneling, you can't control the port number, and they tend to be unstable and shut down or lose connection. A little more secure is our reverse proxy service, which launches a connection for you over HTTPS, and we maintain it and keep it up and running for you. So again, here's a picture of a notebook. It's not secure. When you see that, you should be alarmed and realize that somebody could hack into your web browser, your cookies, and see your messaging that's going over the wire. So our policy is you cannot mount these directly to disk like Jupyter Hub portals. We don't allow that. They have to be remotely mounted, and then the communication has to occur between the portal and the service, because many use root in vulnerable ways. No applications are allowed to run on the login node as well. And then we recommend that you use secure connections wherever possible. So methods for running notebook, I briefly described a couple of them. The security concerns are we using HTTP or HTTPS? HTTPS is encrypted. Are you using SSH versus SSH tunneling? And then what's happening with your browser cookies? So the different scenarios that you can connect with are you connect over HTTP, you can use tunneling like I described, and reverse proxy server. And next year, we hope to have a script that runs on your notebook that launches a secure notebook for you without you having to log on. Right now, you do have to log on to Expanse to launch the notebook. Okay, so why is it by default insecure? You say, well, I logged on to Expanse and I'm using SSH and I launched my notebook. Why is that insecure? Well, what happens is on Expanse, no matter what node you're on, Jupyter will launch a server that opens up on a port. Typically 8888 is the default, but you could set a port. And you think, well, that's secure, but it's not, because then you put that URL gets generated and you type it into your web browser, but it's over HTTP. This connection is secure. That connection is not. It's vulnerable to being hacked. Now, if you want to go to supercomputing, launch a notebook over HTTP, in the old days when we were in person, people will be watching and monitoring through that and trying to hack your connection. So we've decided to try and come up with a solution for that. And that's where the reverse proxy service came up. The SSH tunneling is very secure, and I'll show you a diagram in a moment. But like I said, it does have different problems that are associated with it. It's a little complex. Once you learn it, it's not so bad, but it takes some learning. And like I said, it's not as stable as we'd like it. So why is it secure? You're on your laptop and you SSH over to Expanse, for example, to launch your notebook. And once you launch your notebook, a port gets opened up, and that same Jupyter notebook service is launched on HTTP. But what you do is you connect that port to a port on your laptop, and now all of that communication is done through an SSH connection. So it is listed as HTTP, but your connection is secure. And again, this is very secure. You're welcome to use it. It will be a lot more secure. And if you can keep track of the ports and keep things running, that will be quite acceptable. And you can be confident that once if you get the SSH tunneling up and running, you're secure. And that's great. But if you're teaching a class and you need your students to come on fast, or you want to launch a bunch of notebooks, well, that's going to have a scaling issue as well. So the local port forwarding, this is just an example of you have to set up a connection to define the ports, and then you can launch your notebook, and then it shows as not secure, but it's through that secure tunnel right through here. There's no communication anywhere else except through this secure connection. The reverse proxy service is a way to make this simpler for users. That was our goal. So reverse proxy takes some kind of request from a remote client, processes it, talks to the web server, gets some action done, the server returns information, and then the proxy returns the response back to the user. So it kind of gives you a firewall between the remote client and your service. So we came up with this idea for applying this to Jupyter notebooks. And basically what happens is you come in and log on to, in this example, it shows Comet, but it works on Comet, Expanse, TSCC, and Stratus, all of our HPC systems. So you log on, you run some code, you have to check out the repo, run some code to a start notebook, start Jupyter script, and the script does some communication for you. It communicates with the reverse proxy server here. It gets a token back and creates a URL for you, to use here, and submits a job to the batch scheduler to get an interactive node. On that interactive node, it launches the Jupyter Notebook server or Jupyter Lab server. It's still HTTP inside the internal network of Comet, so it's behind the firewall. The server talks to the reverse proxy service, and that makes a connection between the HTTPS connection that you've got and the internal node that you've been assigned to run your notebook. So it's guaranteed to be secure outside of that firewall. And it's as secure as the current Comet internal networking system can be. So it's a prototype system, and we're in early production on it. And the notebooks are hosted internally, like I said, and it's available to you as an HTTPS connection. And that's all you have to do. And once you learn it, you can launch quite a few notebooks. We think it's very simple, so I'd appreciate feedback from anybody who does start trying to use it. To use it, you SSH onto the login node. I'll show you. You activate your Conda environment. You have to get that installed. And warning, it can take some time to install your Conda environment, as in several minutes, if not a half hour in some cases. So make sure you've got that Conda environment set up before you even try to run a notebook. So but then you have to activate it, and I'll talk about that in a moment. And so you want to clone the repo and get some notebooks and launch the notebook, and try and run a notebook. And I'll show you examples of all of that. To activate your Conda environment, the installation recommends that you put these lines in your .bashrc script, and it can work. I took an example. I commented mine out. It takes a while to launch that Conda environment, especially through the login process. So it can to make your login processes take a long time. So we recommend that you just log in, and if and when you want to run Conda, just activate it from the command line. So for example, here I'm trying to find Conda or Jupyter, and it's not there. I activate my Conda by running a couple of commands, and I can find Jupyter. So the next thing you want to do once your Conda environment is activated is you need to clone the repository and get that downloaded and go into the directory. And you'll see a couple of scripts. The one you want to work with is start Jupyter. I highlighted, yeah, you want to run start Jupyter, and you can run a help command. Sorry, I'm making a note. And it tells you that the different arguments, there are defaults for partition, the top level directory you want to, where your notebook is residing. The project allocation number, you need to have that project number. This is new from other machines. The batch script that you want to use to submit. And right now we have some that we've written and we support. You can do some modification of them and make your own, but be careful. And then the time you want to run and getting extra information about the job, and then choose between Notebook and Jupyter Lab. So the newest version of the server uses configuration file. So as an admin person or just somebody trying to put this onto a different machine, and we do have the reverse proxy server code up on, you can download from the repository. You can configure your machine. Okay, so here I'm going to remember, you need to remember to load the Slurm module. When you come onto Expanse, you start with almost nothing in the environment. And this is by intent, so it does make people cleanly form the environment that they need for a particular application. So for the notebook, at the minimum, you need to load the Slurm so you can run SQ, scancel, and our script actually submits a job to the batch script for you. So it needs to know where about the batch command. So here I'm going to start Jupyter. I'm going to put in it. This is a fake account number. So you would put in one of your account IDs and your own username. But once you do this, very quickly, you'll see this URL. And that's the one that you're going to cut and paste and put it into your web browser. This is the only icky, sticky bit about running notebooks is you have to get that, remember to copy and paste it and put it into the web browser. Again, we don't save this, we don't do anything with it because that's a password to your account through a web browser. So be careful what you do with this. And it's only good for the lifetime of your notebook process, which default is 30 minutes. And there's a limit to interactive. I think it's 2 hours on Expanse. If you have any issues, contact the Expanse help desk. So that you get a job ID. And so the first thing you want to do is look at the job ID. So you run the SQ command, looking for your username. The reason you need to do that is if Expanse is busy, like Comet, it can take a long time just to get the allocation, to get that node. And if it's very, very busy, it can take an hour. We can't control that yet. We do have plans for a set of interactive queues to nodes to be available in the future, but right now you're just in the mix with all the other users running jobs and accessing the queue. And so it can take some time, and you just have to be as patient with getting a notebook from the queue as you would if you were submitting a job. But what we do is if you paste that URL into a web browser, Remember, the notebook URL is a password. Don't share it. Don't give it away. But what you're going to get first is a waiting page. It's a placeholder that the RPS produces and gives to you while it's waiting. And this won't change until you get something from the queue. And when you run the queue command here, eventually you'll see that it's not pending. You'll see that it's actually running. So you might see this in all kinds of different phases, but once it starts running, you'll have a Slurm output file with a little bit of information in it, but that still doesn't mean your notebook is up and available. It won't be up and available until this screen changes to your notebook. And you'll be able to see it's your notebook because it's secure and it's got that token and that URL that you put in from the reverse proxy server. And then at this point, it should run like normal. We're still accumulating information and data about how long this can take. But if you do get a notebook launched and you do see that your job is running and you find yourself waiting for 15 minutes or 20 or 30, please submit a note to the consulting team so we can start debugging why this might be, if there's some issue associated with our server. And information we would want is everything you see in this screen and the Slurm script, the job ID, like you could just attach this output file so you can help us debug it. When nobody's on, it happens very quickly. So at this point, I do have time for a live demo. So I'm going to end the show. You can ask questions if you want while I get this set up, but hopefully I am set up for this. Okay, let me get this out of the way. Okay, so can you guys see my screen?
Yes.
Okay, and so I try to make the font big enough. Can you guys read the font? Or should I just go a little bit bigger? Okay, so I always use aliases, so when I type Expanse, that logs me on. Okay. So I'm in my home directory, and what I'm going to do is make a test directory and go into test, and I'm going to clone the repository. Right, so you can see I've cloned it a lot. Just to show you back here, I have a web browser ready to show you different web browser locations. So this is our notebook examples. We have a lot of notebook examples that are tested, and to our knowledge, they run on Expanse. They run on all the machines. There is Pandas Pandas database plotting routine here. Boring Python is basic introduction to Python. Python series is also some introduction to Python. Web scraping, just different examples of code that should work for you as well. If not, give us a note so we can track the issues. The repository, this is the reverse proxy server. So really you would just copy this and type git. Let's get this back up in here. Git clone the repository here. Trying to make this so we can all see it. So I'm cloning the repository, and while we're looking, here are there's the different notebooks that you're allowed to use, or that we support is the way to think of it. You can go into them and make a few changes, but one of the things you don't want to do is edit anything below this line. It might not work so well. Okay, and then for Notebooks 101, this is a link to the tutorial. And we do have a new user guide that we're launching where you can see the Comet 101, the Expanse 101 tutorial, and the notebooks you can navigate through and learn and see our hints on how to install. The Conda environment, there are lots of tutorials out there, but for our tutorials, they're customized to our machines, and they should, every command should work on your machines. These are just coming from a simple README, so you can cut and paste and make those commands work. All right, so now we've got our repository cloned. And so I'm going to go into this. This is the master. If you look at the config file, you can see we've got our different hosts. And again, this is written to scale out, and we're working on making it more user-friendly. But this is a new change. We've updated this from the one that we've had in recent. This is a recent update. And again, the idea is you could go to the repository here, and I'll show you there is the satellite here. That is the reverse proxy server posted and maintained by Scott Sakai. You're welcome to try and host one. I think it just needs Apache. And Scott will be welcoming input and feedback on that. But I'm talking to the one that we've mounted and installed on Expanse. And so the next thing is we want to try and run a notebook. So if I do start Jupyter and I do a help, then you get your feedback. There is a default mode, but it's going to be unhappy because I didn't give it my account number. So I'm in use 300, so I'll use that project ID. And I forgot to do something. I forgot to activate my Conda environment. So let me see, I have to remember all the little commands. So I'll go back to my home directory, and where is my Conda activate text, my little reminder file. So I'm going to run these two little commands. And then Conda activate. And now it will find Jupyter. Whoops. So now it finds Jupyter. So that's an example. So now we'll go back into our directory. Since this is your own local Conda environment, and you're going to be installing your own Conda packages, your own application packages, we keep it all so that you have to have your environment up and running. And so there could be a global Jupyter, but we want to run this experiment of everybody configuring their Conda environment. So far, the only downside we can see is that everybody, if you have 20,000 users on Expanse, everybody's going to have a copy of the mini Conda environment on their local directories. And so that might add to a lot more need for storage, but that would be a trade-off in capability. Okay, so now I'm going to start Jupyter, and I'm going to give it my account and just let it run the defaults. Notice it said, oops, can't find SBatch. So I'm going to load the module. So this is using the Luau module system. And again, like I said, I logged in and I did not really inherit very much. So you have to make sure that the modules that you need are the right ones. And that requires a little bit of training, but we do have some tutorial material for that. Okay, so now I should be able to submit a job. There we go. I got back a URL and I got back a job ID. So let's look at the so I have a job, it's pending, but while it's pending, I don't have an output file, but I can go to my browser and type in, oh, that's not what I wanted. I wanted to type in this. Okay, so now we're waiting. So I'm going to sit here and wait, and I'm going to run the SQ. It's now running, and so I have an output file with some information, which when the job does finally finish, will also get appended to this. So there's a little bit of information that gives you some idea. But again, you'll notice we've had a lot of debate about whether we should give you the full URL in case you forget it. And because it's a password, we're being very careful in trying to find a secure solution. And so this could take a few minutes. And while we're waiting, does anybody have any questions, or is there any questions? Are there any questions I can answer, Jeff? Oh,
Marty's been pretty on top of it.
okay. Now it's not happy with me. This is a different mode. This is called a demo. I don't know why. It shouldn't be asking me for this, so I must have mistyped this. So let me get the URL again. You can have it run so that it asks for a password. This should have just come along with the token. There we go. So if you mistype, it still launches, but you need that password, and that's that token. So here's our notebook. And again, I'm in my home directory. This is why, and Scott Sakai is just drilling it home into my brain, and I'm going to try and drill it into yours. This is a password to my directories. You can see what's in my directory. It's not limited to just what is Jupyter-y, notebooky. It's everything. You can see all of my files. There is a limit to where you can navigate, but a hacker might have already figured this out. But this is secure. You can see this is HTTPS, and that gives you as much protection as we can supply you right now. So I have checked out and cloned the notebook example repository. Sorry, I went through that too quickly. Again, the only one I would, maybe I haven't tested in a while, is the CUDA. And that's what you have to run things a little bit differently. So everything else should be working fine. Some of these are applications created by my summer students, the research for experiences for high school students. So you can go, but Hello World should always work, right? And so we'll just see, we've launched it, and here's a Jupyter notebook. So I can run all the little kernels. There we go, and it worked. And again, you could add 1 plus 2 and run that, and we should get 3. This is why Jupyter notebooks are so popular. I'm making changes in my code. It's being saved. It's compiling on the fly, and it's on a supercomputer, so I can access remotely my petabytes of data that might be out there. And it's very popular for machine learning. We have 2 or 3 webinars and seminars that we give every year as part of our institute, and I'll have somebody do a machine learning webinar in the spring. And so you get on the GPU and run your machine learning code on our large number of V100s. So that sort of concludes my live demo and my presentation. And there's time for any more questions if you guys might have them. With that, I can stop sharing.
So there was a question about doing a demo of SSH tunneling. Marty pointed us to a link to the GitHub tutorial on tunneling. I don't know if there's anything else that we would want to cover on that.
I'm not going to do a demo. No. I'm not set up for that. But I will add that link. Any other questions?
I think that's it.
All right. Well, I hope to see you guys on Expanse. And this works on Comet, like I said. And the new version has been tested for all of our machines. So even if you're still on Comet, you'll be able to. And if you're an admin type person and you want to install your own reverse proxy server, we're working on getting this robustified, debugged, and trying to get this out onto Exceed systems as well. So Scott would be really happy to see somebody launching that satellite server and be happy to help people get that up and running. And thank you guys for joining. Happy holidays. Have a safe holiday season, and we'll see you at the next webinar or workshop. Take a look at our training material for events coming up, because there'll be several that are going to be new material.
Thanks very much, Mary, and thanks everyone, and have a great rest of your day.